In this video, we'll look at the derivative of a polynomial with a whole bunch of different polynomials. The first one is y equals x to the power of 4. To take its derivative, y prime, we bring the exponent down, make it the coefficient, so this 4 comes out in front as a coefficient, and we subtract 1 from the exponent. So the derivative of x to the power of 4 is just 4x to the power of 3. Bring the coefficient down from the exponent and subtract 1 from the exponent. Let's do it again with a different question. Question 2, y equals negative 3x squared. The derivative is just bring the exponent down. This time, make it the coefficient times this. In other words, bring the 2 down. It's negative 3 times 2 is negative 6. And subtract 1 from the exponent. So the derivative of negative 3x squared is negative 6x. Bring the exponent down, multiply it times the coefficient, and subtract 1 from the exponent. The same is true if your equation is linear. For example, y equals negative 9x. You can just think of this exponent is a 1, so bring the exponent down. You get negative 9 times 1, which is negative 9. And then subtract from the exponent, you get x to the power of 0. And if you know your exponent laws, x to the power of 0 is just 1. In other words, the derivative of this linear function is just negative 9. Why? We brought the exponent down, times it by the coefficient, and subtract 1 from the exponent means there's no more x term. What about when you try and take the derivative of a constant? The derivative of a constant is a little bit of a surprise. It helps if you understand that this is the same as 5x to the power of 0. So when you bring this coefficient down, you'll get 5 times 0, x to the power of negative 1. Same rule. Brought the exponent down and subtracted 1 from the exponent. But watch what happened. 5 times 0 times anything, it's all times 0. The derivative is just going to be 0. So at some point, you won't even need to show that work. Hopefully, by the end of this video, you'll just be able to jump right from the fact that if you're taking the derivative of an equation where it's just a constant, the constant's derivative is always 0. For the reason I just showed, you can jump right to here. Let's see if we can put that all together. Suppose I give you a polynomial. Question 5 here is a polynomial made up of the 4 previous questions. To take the derivative, you just simply take the derivative of each piece. That is, what's the derivative of x to the power of 4? Bring the 4 down, subtract 1 from the exponent, 4x to the power of 3. What's the derivative of negative 3x squared? Bring the exponent down, multiply it times the coefficient, subtract 1 from the exponent. What's the derivative of negative 9x? Bring the exponent down, times it by negative 9, and now the x disappears, just as it did over here because we subtract 1 from the exponent. And finally, what's the derivative of a constant? Nothing. And so we're left with the derivative of x to the power of 4 minus 3x squared minus 9x plus 5 is just 4x cubed minus 6x minus 9.